numerical data using two variables. A way to show numerical data using two variables. And when we use our two variables on a graph, what two variables might we use? X and Y. All right, we're going to talk a little bit about scatterplot that's already done for us, and we're going to talk about the needs that a scatterplot needs to have. What are the different parts or the different things of it? So when you get this glue in, you can glue it in. I would glue it in near the middle of the page, so that way you can kind of write on both sides. Can we pause that and pay attention? Alright, so go ahead and glue that in the middle of the page, not middle of the page, but in the center of the page. Don't glue it further down, but just toward the middle. Alright, so go ahead and get that glued in. Alright, so gluing it at that line, but just making sure it's kind of in the center because we're going to write on both sides here. Alright, I'm going to use a couple colored pencils here. If you'd like to, you can. This one is probably something that you don't have to use colored pencils for. So if you're somebody that you're like, oh my gosh, Miss Moran, her colors, I can't. Today is fine, you don't have to, but it might help. It might not help, I don't know. I'm going to use colors to kind of highlight the different parts that are important. Alright, so first off, when we look at this graph, sorry, a couple of people are still gluing, give you a second, glue that in. Alright, as we take a look at this graph, what are some things that we notice? What are some important parts? Good, there's dots. So each of these dots represent our data. So that's our data points. In each of those data points would be a ordered pair that goes our X and then our Y. What else do we see? The title. Good. So title, what is our title here? Good. Average water students drink. So that's a really important part. And that's really what I'm using colors for, is to draw our attention to the important parts. And this is called our title. Okay, what else do we see that's important? We're just looking at what creates this graph. Good, our X and our Y axis. So which one is our X axis? Temperature. So our X axis is going this way. So this is our X axis. And then this temperature, we call this a label. And that label goes with that x-axis. All right, what do we see is another important part? Y-axis, which goes up and down, our vertical. And in this problem, what is our y-axis telling us about? The water we consumed in ounces. So this part here, this is our actual y-axis. That line going up and down. But then this water consumed is our label. So throughout the day, the overall title, this is telling us about average water students drink. What are we measuring? What two things? What are our two variables? Good, the temperature and how much water we drink. Good. So temperature, what are we noticing when the temperature goes up? What's happening to the amount of water we're drinking? It's increasing. So do you think this is the temperature of the water? As water gets hotter, more people drink it? No, what do you think that temperature is probably talking about? Not the temperature of the water. When water gets warmer. Oh, weather. Sorry, weather. Yeah, when it's hotter outside or even hotter inside, what do we generally do? Drink more water. We get thirstier because we sweat. Now, there's one other part that's really important here that we didn't highlight yet. And this one's probably, I would say, is the most important part. So if you're going to use one color today for sure, this is where you need it for sure, or use a highlighter. There's one part we didn't talk about yet, and that's this little squiggle. This little M-looking thing. Okay, that's really important. This guy here. So circle it, highlight it, do something. Okay, this is called a break. And when we look at our data, if we look at our x-axis, what is our x-axis counting by? It's labeled as 5s. Technically, it's every 2.5, but yeah, they skip every other and do 5s. And our origin, where our x and our y-axis meet, is always what number? 0. So does this consistently count by 5s from 0 to 100? No, so this break jumps because maybe we didn't have any data up until 80 degrees. And if we didn't have any data, if we were going to count by 5s from 0 to 100, we would have a bunch of lines that would have no data. It would just be a blank part of the graph. So we use that break when we jump from 0 to the first number. I'll get that in 1 second. I'll write this down first. Use when we jump from the first number, or when we jump from 0 to the first number. So if we have like a really big first number, like if the first number didn't start until 1,000, but then after 1,000 we should maybe count by 10s or by 50s, then we use that break. Alright, so when we jump from 0 to the first number, we use that break. Alright, next thing we're going to talk about, we have a couple of things we just with a lot of vocab today. The next thing we have is correlations. So I'm going to do that little line across, kind of going to a new idea with scatterplots. And that's correlations. Correlations. So when we look at correlations, and that word, what is our base word? What word do you see in that word correlation? Core. You're right, we see core, but that CO is actually a prefix. It's co. It's goofy because we don't say it as co because that R makes it like a core, but it's actually co. So that's our prefix co. And what does the prefix co tell us? Yeah, together. So like a co-worker means you work together. So good lately, man. Okay, you work together. If you cooperate, you're working together. Okay, so co is together. And then what's our base word? Relate or relation. So it's our relationship together. So it's how two things relate to each other. How two things relate to each other. So how are they related? All right, so I'm going to break this up. There's 3 different correlations. So I'm going to kind of draw some lines here. I'm going to draw 2 lines so that I have 3 spaces. So 1, 2, 3. Isn't that yours? No. Oh, it's not in there? Whoops. All right, so we have a positive correlation. Perfect. We're about halfway down the page right now. All right, so a positive correlation, if we think back to a graph, when we talked about a positive slope, which direction was a positive slope going? Up to the right. So positive, if we look at these points, our points are going up. Okay, your points don't have to be exact. We're just making points and trying to make them look like they're going up, kind of uphill together. Kind of all over the place, but there's one way up here by itself. I don't know. But overall, they're going up. And what this means is it's a more relationship. It's a more relationship. So the more that one thing happens, the more the other thing happens. So for example, in our first problem here that we glued in, it was the more temperature, or the warmer it is, then what? The more water we drink. It's going up together. Okay? Or it could go down together. The colder it is, the less water we drink. Okay? So really a big one here is like if you're in a sport, or if you like to draw art, or if you are just trying to pass math, the more practice time you have, what's going to increase based on the amount that you practice. If you practice more, then yeah, you get better scores, you do better, your skills increase, right? So your amount of skills is what I was going to go with. If you're thinking more specific, like you want to think about this specifically to drawing, you could think of the more you practice drawing, the more accurate your drawings are. If you're practicing basketball, maybe the more baskets you make, or the more wins your team has. So that's just an example. All right, after positive correlation, what do we think is our next correlation? Negative. Good use of your deduction. Have positive, negative. If positive means that our points are going up, what would negative mean? Yep, points are going down. So they're kind of starting up high, and then as they start up high, it works their way down. And again, our points aren't all on one line, they're scattered around. But overall, they're working their way down. That was maybe a bad point there. All right, this problem works with a more less. So they're going in opposite directions, which makes it negative. More or less. The more of something, the less of another thing. So a lot of times this has to do with thinking about like the amount that we're starting with, and as we do something, as we start, that amount is getting less and less. So maybe think about your energy in the day. As you do more things in the day, what happens to your energy? Yeah, it goes down. Your level of intensity might go down. The more you play in a game, like if you're in basketball, the more you have playing time, the less energy you probably have, right? Okay, or we can think about our computer. You guys all have a computer, right? As you use your computer more, you spend a lot of time on your computer, what goes down? Your battery. Your battery percent. If you spend less time on your computer, the more percent you have. You got that pass. Okay, so the amount of time you spend on your computer, the less battery you have if you spend a lot of time. Or, if you don't spend a lot of time, the more charge you have. All right, last one. We have positive, negative, and our last one is no relation, or none. Our last one is no relation. So when we look at the graph of a no relationship, they don't relate, there is no correlation. That means that our points are all over. They're not going up, they're not going down, they're just kind of scattered. There might be like a little clump here, but overall, they're all over. They're not going up, they're not going down. So it doesn't matter if something's getting more or something's getting less. They don't have anything really to do with each other. So for example, the temperature outside. What's something that the temperature outside would not affect?
A tree.
The trees? They would maybe. Like if it gets to like negative 70 degrees, the trees might die. Right? What about like the what?
House. Inside the house.
You're crazy. The temperature outside and maybe like the number of pencils you have. Can we do that?
What happens if it's too cold in your house and you have to burn wood?
Okay. Now you're getting into the real hypotheticals here. All right, so when you get up in the morning, do you look at the temperature and say, oh, it's going to be 60 degrees, I need 4 pencils today?
Maybe if you're weird.
Yeah, maybe if that's like your little tick. But again, that's getting really specific, right? Okay, so as we take a look at this with our number of pencils, or does the weather change if I grab a handful of pencils? Does the weather change automatically outside? No. In the winter, do you need more pencils than you do in the summer? No. They don't have anything to do with each other.
Maybe you're like shivering a bunch, so like you break your leg if you like.
Okay, maybe. I guess. God, real creative here. All right, we have one more thing that we're going to do. So I know this feels like a lot of notes, but again, it's just kind of an intro, and hopefully this feels a little bit like review. So we're going to make a scatter plot. So we're actually going to, we have data here, and you're actually going to plot and make a scatter plot as we go through. So I'm going to my next page to glue this in.
Another one.
This one time we're actually going to make it and plot it. Okay, give me 1 second. I'm in the middle of passing this out. You have to pass me after you come here. I still didn't grab it. Oh my gosh. Okay. 1, 2, 3. 1, 2, 3. Dang, you don't get one. Because I keep forgetting it. All right, Joel. Go real quick.
Go?
Yeah, but take your computer with you. What? Okay, you gotta take it with you. Because that's the rules that apply. Okay, doesn't matter if you follow the rules. Alright, so go ahead and get that glued in. We're gonna create our scatter plot. Make sure that has everything that it needs. As we go through it, very often when we create a scatter plot, we forget some of the basics. All right, as we take a look at our data, what are we seeing for our data? Good, we're talking about our test scores and our minutes practiced. So what might we title our scatter plot? Test performance? Sure, I like that. Last year we titled it Practice for a Test. We went real simple, but test performance is really fancy. I like it. All right, here we have our X going across on the bottom, and we have our Y going up and down on the side. So as we take a look at our test performance, we're talking about our minutes practiced, and we're talking about our actual grade in percent. So as we go on the X is usually always our time, if there's a part that's time. It's our independent variable. So here we're going to have our practice time. If you wrote it exactly the way it was here and just say minutes practice, that's fine too. I'm going to write practice time. And if I write practice time, I'd leave a little space there because we are going to write some numbers in between. With practice time, it doesn't say how we're measuring it. So I do need to write down how we're measuring our practice time. Are you measuring it in hours, days, weeks, minutes, seconds? Minutes. So we do have to write that minutes there. And what are we comparing to our practice time? Our test grade. And how are we measuring a test grade? Is it just the score you got? Yep, it's our percent. So this test could have been out of 20 points. It could have been out of 75 points. It could have been out of 100 points. But we're going to measure it based on your percent. All right, now that we have everything labeled, we're going to now decide what we are going to count by on our X and count by on our Y's. So as I look at my X, that's our practice time. I always just kind of look for our minimum and our maximum. So in our minutes practiced, what's our minimum? What's our lowest time we practiced for? 5 minutes. What's the most we practiced for? 133. 152? Oh, right there. Yep, 152. Okay. So remember, practicing for a test isn't always like sitting down and studying your notes. Sometimes practicing for a test is literally doing your homework or looking over your notes or reorganizing things. Those are all practice times. Okay? All right, so as we look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have about 17 lines. So if I have to get up to 150, what would I maybe want to count by? Probably just tens. If we count by tens, that would get us to 170 or 160. Do we need to make a jump from 0 to our first number? No, because our first number is just 5. So we're still going to start with 0 in that bottom part there. Now remember, when we label on our x-axis, we're labeling these lines. So on this line here, we'll have 10. And then the next line is 20. If you need to skip a line, you can, but make sure you're still counting by 10. So if you're skipping lines, it'd be 0, 20, 40. Okay, or make sure you're writing small enough that you get each of those lines. So we're always measuring those lines coming down. If you need to put those little tick marks there to show yourself that that's what we're measuring, that might help. Thank you, Amin. Do you want a box? Okay. 110. If you started like I did, you should go up to 160. All right, now on our y-axis, this one is always up for a little bit of debate between classes. Our y-axis, what is our lowest grade percent that we have? 32, that's pretty good for somebody who only studied 5 minutes. They only took notes for 5 minutes of their life. They were watching TV on their Chromebooks their other times. All right, so 32, and then what's our highest percent? 100. So we have about 10 lines here. Do we want to skip from 0 to 30? Do we feel like 3 lines is too much of a waste?
Yeah.
We do? 3 lines isn't, that's the debate part. 3 lines usually to me isn't that much of a space. If it was like over half was going to be blank, then we want to make a jump. But when it's only the bottom 3 lines, that's not too bad. So I'm not going to make a jump, especially my big reason why is if I didn't make a jump, could I count by 5s? So if I did 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, it's not going to change how I count. I'm still going to have to count by 10s either way. So either I'm going to have blank space on the bottom or blank space on the top. Unless you want to go by crazy and count by like 8s or 7s, you do you, but that sounds crazy to me. I like to keep it simple. So I'm not going to personally do a break. I'm going to start at 0. And then by test grades, I'm going to count by 10s. So we have 0, and then we have 10, 20. Remember, we're counting those lines, going up by 10s. Oh my goodness. Why don't you just leave it a little cracked on me? And then you don't have to keep doing it. Thanks. 70. And then that should get us right to 100. If you did a break, that would be fine. If you wanted to jump from 0 to 30. Normally we do that break if it's going to help us count better. In this case, it doesn't really. We'd still count by 10s. All right, so next up, all we're doing is plotting our points. So I'm going to plot the first 3 with you, and then I'll give you some time to plot the rest. Okay? And then a quick check, yep. So first one is 35 and 74. So when we look at these, we're looking at them as x and y going up and down. So this is our x, and this is our y. So first we're going to go to 35 on our x-axis. So 10, 20, 30. 35 would be halfway between 30 and 40. And then 74. So up to 70. Not quite halfway to 80. And then we put a point there. Okay, next we have 1056. So 1056. So we go right to 10. And then we're going up to 56. How are you feeling? Making sense?
No.
You're not doing it, Joelle. 73, 87. So 73 is on our X. So 73 will just be a little bit past 73. And then 87 would be up to 80. And then over halfway to 90. Alright, I'm going to give you some time. Finish plotting those points. I'll walk around and help as you need it. But you should be plotting the rest of those points. So you're plotting the rest of these points that are at the top. You're doing it on your own. Alright, how are we doing? All right, so as we go through this and we plot our points, what are some things that you noticed? 42, 65, 125, 80 and 89, 5 and 32, 152, 96, 58, 74. Whoa. 34, 85, 48, 68, 133, 100, 35, 65, 35, 68. Hey, you guys, is there... Nope. Am I insane? I'm insane. 35, 65, 103, 80, 85, 78, 99, and 96. Just kidding, Kivante. I don't know. Alright, so as we take a look at this overall, what's happening with our data? Is this a positive, negative, or no correlation? Positive correlation. The more you study, what should happen? Yeah, it should go up. Are there anyone that's a little bit goofy? Somebody who didn't study who did really well? Yeah, which point is kind of like the one that maybe they knew it before, or they really listened just to the notes, and because they listened so well in the notes they didn't have to practice? Yeah, that 10 and 55, that one? Still didn't pass. I would go with that 30 one. The 30 and the B. This 30, what was it? 34, 85. Somebody only practiced for 30 minutes and they still got a B on their test. That's pretty crazy to me. Normally you have to at least practice an hour to get into that B's and A's range. Can this go on forever and ever? If you study more and more and more, will your grade keep going up and up and up? Will this keep going on forever until the end of time?
Well, no, because you die.
No, because you would die. Can you keep studying for the rest of your life before you take a test?
You could.
Don't you at some point have to take the test?
Yes.
Yeah, there has to be an end point. At some point you have to take the test. Can you get, depending on the test, can we get more higher than 100%?
No.
No, so at some point this would flatten out. And as well as sometimes the more you study, sometimes there's points where you just need to realize, like, hey, I've done my studying. At this point, I'm just freaking myself out. I need to calm down and just trust myself, right? You know what I'm saying? Do any of you guys get like that? Where you, like, almost overstudy? I do that. Okay.